In this lesson, we have let A be this matrix, B1, B2, B3, B4. Now, last example, if you remember, we solved B1, B2, B3, B4 as individual. We only solve it individually. Now, what if we put all of this together and solve as one? One more time. Last example, we solve B1, B2, B3, B4 as an individually. What if we solve all of them together, put everything together as one? Will it come out the same answer? Okay, so we're going to put A, B1, B2, B3, B4 together as one and solve as one, not individual. Will the answer come out to be the same? So here we go. So this right here is our A. This is B1, B2, B3, B4. Okay. And if you remember doing row operation, if this is a 1, just leave it alone. Okay. If it's not a 1, multiply the reciprocal. If there is a negative, don't forget to put another negative so it will become a positive 1. One more time. Since this is already a 1, leave it alone. If it's not a 1, multiply by the reciprocal. If there is a negative, put an extra negative so that it becomes positive. Okay, so again, this is already a 1, leave it alone. So the first row, leave it alone. We want this 5 to be a 0. So opposite of 5, it will be negative 5. So negative 5 times row 1 plus row 2. So to get 5 becomes 0, we do the opposite. So instead of positive 5, it is negative 5. So negative 5 times 1 is negative 5. Negative 5 plus 5 gives me 0. Negative 5 times 2 gives me negative 10. Negative 10 plus 12 gives me 2. Negative 5 times negative 5. Negative 5 times negative 1 gives me positive 5. 5 plus 3 gives me 8. Negative 5 times 1 is negative 5. Negative 5 plus negative 5 gives me negative 10. Negative 5 times 2 gives me negative 10. Plus 6 gives me negative 4. Negative 5 times 3 gives me negative 15. Plus 5 gives me negative 10. Okay. Next, we want this to become a 1. So we need to multiply the reciprocal of 2, which is 1 over 2. Okay, so rewrite this row, first row again. Now we're changing the second row by 1 over 2. Why? Because this is a 2 and we need a 1. So reciprocal of 2 is 1 over 2. So 1 over 2 times 2 gives me this 1. 1 over 2 times 8 gives me 4. 1 over 2 times negative 10, negative 5. 1 over 2 times negative 4 gives me negative 2. 1 over 2 times negative 10 gives me negative 5. Okay. Next, we need this right here to be a 0. As you can see right here, 0. We need this spot to become a 0. So opposite of positive 2 will be negative 2. So we're going to do negative 2 times row 2, add to row 1. Okay, so negative 2 times row 1 plus negative 2 times row 2 plus row 1. Okay, so negative 2 times 1 gives me negative 2. 2 plus negative 2 plus 2 gives me this 0. Negative 2 times 4 will gives me negative 8. Plus negative 1 gives me negative 9. Negative 2 times negative 5 gives me positive 10. 10 plus 1 gives me 11. Negative 2 times negative 2 gives me positive 4. 4 plus 2 gives me 6. Negative 2 times negative 5 gives me positive 10. 10 plus 3 gives me 13. Okay? Again, we want this 2 to become a 0. So the opposite of 2 is -2. Okay, so -2 times 1 is -2 plus 2 gives me 0. -2 times 4 gives me 8. Subtract 1. I'm sorry, -2 times -2 times +4 is -8. Plus -1 gives me -9. -2 times -5 is 10. Plus 1 is 11. -2 times -2 is 4. Plus 2 gives me 6. -2 times -5 gives me +10. Plus 3 gives me 13. And we are completely done because this is 1, 0, and 0, 1. And that's what and that's what we need. When we have 1, 0, 0, 1, we are completely done. And if you look carefully, this is our answer for B1. This is our answer for B2. This is our answer for B3. And this is our answer for B4. Okay, so one more time. This is our answer for B1, B2, B3, and B4. So the last example we did was we did individually, and it came out to be this answer, this answer, this answer, and this answer. However, in this example, what if we put all of them together and solve it as one matrices? And they did came out the same answer. Okay, so one more time, last example, we did individually. This example, we put all together and solve as one matrices, and the answer is still the same. Okay, so there's two different ways to solve. You can do it individually, or you can do all together as one matrices. Okay.